start the demo class, I'd like to give a short introduction about me. My name is Namit Taneja, and I have an experience of total 6 years, and close to 3.5 years. I've been working with the Hadoop and the MongoDB and the big data stuff. So I'm a Cloudera certified Hadoop developer, as well as I'm a Indian certified MongoDB developer, as well as DBA. So that was actually all about me. So now we will actually start with the presentation, and that all of us are here actually to get a better idea of what actually is Hadoop. There is a course being run by BEST, and that is developing solutions using Apache Hadoop. So what is up to me, like what I'll get out of this course if I attend this. So that is a kind of a gist I will like to communicate it to you across after the end of the class. Like when you go out of the class, you have a clear picture. If I'll attend this thing, what basically will I take out of the course? So to just let everyone be on the same page, we'll just start with the agenda. Yeah. So here we are. Hadoop, as you can see, the symbol is elephant. You can see that across. So our motive should be how to tame the elephant. It's actually we use the elephant synonymous both for the big data as well as the Hadoop. So the agenda which will be there for the today's class will be the introduction has already been done. Then I'll make you I'll ask from you actually that what is big data. Then we'll see how does big data different from traditional data. Then what are the challenges which big data comes across? Okay, big data is coming, everyone knows, but what are the challenges which it brings along? Then the big data architecture. Then the coming to Hadoop. Okay, big data is there. Then we have heard something is Hadoop. So how can it help us? We'll look into that. Then you guys would have also heard there is something NoSQL coming in. So I'll actually like to spend a bit of time on NoSQL part also, to give you a fair bit of idea about what is big data, what is Hadoop, what is NoSQL, and then some security issues and the big data. So I'll try to cover maximum of that. Main intention of me will be after the class, you guys should be very comfortable with some of the things. Okay, what is big data? What is Hadoop? What is NoSQL? What is different between Hadoop and NoSQL? Are they the same thing? And how are they going to help us tame the big data or the big data? So that's actually our intention. Okay. So if you guys have any question in between, you can surely put that across. Okay. So now this is the normal introduction, but first thing I'd like to ask from all you folks is, can someone tell me what is actually big data? All of you come here for getting a kind of insight on what Hadoop is. Can I have an answer from you? We'll actually make it a bit more interactive so that even you don't feel bored, and even the class gets along very well. So can someone tell me what actually is big data? Saurabh, Balaji, Deepak, any one of you, if you can come up with what actually is big data.
Basically to process the data very fast.
Who's this? Who's this? Who's this? First of all, please tell us.
This is Rajesh.
Okay. Yeah, Rajesh.
Basically, big data is used to process the large amount of data.
Okay. Saurabh, Deepak, Balaji, any of your comments on this? I would love to make this interactive because I can surely go ahead with saying what big data is. Yeah.
As per my knowledge, every data can be considered as a big data. It is just when we go on with the collection of unstructured data, we might be terming it as a big data.
Okay, wonderful, wonderful, wonderful. Yeah. So I guess almost all of you folks out here have a fair bit of idea about what big data is, but still there is a kind of an ambiguity over there. Okay, big data is something which can solve problems. What is big data? It is unstructured. So just to put it very clearly, just in another 2 minutes we'll be utmost sure of the fact what is actually big data. So yeah, so what is big data? Big data is something which consists of all three V's. This was the best definition which are actually found across everywhere. So big data is something, any data which has got huge volume. Big data is not a solution. Big data is a problem where the data is very big. So if the data's volume is very large, that is the volume of data is actually in the measures of zettabytes, then I'll call that data as big data. And from where that volume is being generated, every time you're clicking something on the Facebook, you're liking a photo, you're commenting on a photo, you're subscribing to a channel, you're liking a page. So all those are getting stored somewhere. You tweet something, you're trending something, you post a new news feed in the LinkedIn. So everything you browse actually goes into the net and makes the data as big. So that is something, if the volume is very big, we'll call the data as big data. So then the velocity. If the velocity with which the data is getting generated, if that is very fast, then also we'll say the same thing, that the data is very big. Then the third thing is the variety. The variety means the data which is being generated. I can easily say that some of the data being generated is actually structured, some is structured, and some is semi-structured. So to just give you a bit of what is structured, what is unstructured, what is semi-structured. Structured data is actually where we have a proper template where the data comes in. We have a proper schema with say there is a table with 5 columns, the data will come in like that. So we have a schema and every data would comply to the kind of schema which is there. Unstructured is we don't have any structure at all. One field can have 10 records, other record can have 100 records. So no column, no fixed schema, nothing. And then the semi-structured where the data is not actually in a schema, but still we can find a pattern out there. I can ease out how the things have been stored. Like all the data coming from Facebook, Twitter, how it is being internally stored is actually in a semi-structured format. Related to FB, if you create a FB post, so everything will have the first field at created at, some is unstructured, then also the data is very big. So the main thing is we don't need all the three V's to be together to make this data is big. If it has high volume, it can be big data. So all the three V's need not be together to contribute to big data. Any of one V will do. I keep the presenter right now. Hold on for a second. Everyone is able to see my screen now?
No, I am not able to see your screen.
Okay. Just wait for a while. I'm not the presenter. I'll make me the presenter. Wait. Done with what actually is big data and which data we can actually classify as big. So now we'll actually delve deeper into any one of you, if you have any questions in defining big data, you can surely put that across. Any one of you, any doubt between what is structured, what is unstructured, what is big data, how the volume, how the variety, how the velocity. So any doubts of now, you can put that across. Okay, so I guess we are good to go. Yeah. So now when we understood the data, now we'll actually see what is the problem, how traditional RDBMS system used to work with the data. So you can see there are 4 servers. There are 4 servers. Inside that, when the data transfer happens, first of all, there will be one server, but as the amount of data got increased, you have to make several servers. Someone is working in. Okay. Just breaking. Once again. we were doing how the traditional DBMS actually deal with data. So here in the middle, we are able to see that we started without one server. In SQL Server, Oracle, all of you guys would be working MySQL, Postgres. What happens is when my data increases to a certain level, so we need to increase the server size. If there was one server, now we will be having 2 servers. So here we can see the 4 servers are there, and because these 4 servers have come to picture because the number of users have increased, the current database is increased. But now when we want to retrieve information and say information is in server 1 and some in server 2, so we need to make a join between the 2 servers and get the data. So at that time the data transfer suffers because the data has to travel across the servers and get to the the person who is actually querying the database. So that was kind of a bottleneck which happens if the data increases and there are so many servers. So this was one problem which our RDBMS system were actually persisting with. So now it's fine. We understood what is big data. We understood what was the problem with the traditional RDBMS systems being in place. So now, okay, we understood what is big data, but what challenges does that bring that across? You would have read big data is very hard to handle, all those stuff, Gartner reports and all. So now there are 3 things which make it very challenging. First is the complexity of the data being produced. As you can see, I told you velocity, variety, and the volume. We don't have a proper understanding of the underlying data, in which manner it is getting stored. So I'll have to actually see the patterns in which the data is getting stored in the social media systems. Then the storage. How to accommodate that large amount of data in one single physical machine. So because as you can see, whenever we increase the number of machines, we can see a certain bottleneck which comes when we increase the number of machines. So we don't want to increase the machine size, or you can say machine number, to accommodate the data. And then comes performance. With performance, I'm saying when there is a large data, at present, if you're working in SQL Server or Ecosystem, if the volume of data goes across 1 TB, then also we can see a performance lag. So but here we're talking of zettabytes. So how to process that large amount of data, and that too with good performance and good efficiency. So we have the challenges, we have the data, and we know the current RDBMS is not able to work that thing out. So we need a new approach. What new approach? What are the requirements which would satisfy that new approach? That will be, we need to support partial failures happening. In SQL Server, if one server goes off, suppose if this server goes off, what will happen? My system is gone. So we need to support partial failures. We should be able to recover if the system has gone off, one of the system has gone off. The data should be available all time across all the machines. Consistency, the system should be consistent. It should not be like, I've done a transaction at one place and it is reflecting that transaction one day back, one day after. Data reliability and upgrading. If I want to upgrade the system, suppose I have a system infrastructure in place where I can handle say 100 TBs of data. But after 1 month, what happened? We came to know that no, the data is increased. Now we need 2000 petabytes of data. So the system should be upgradable so that more data could be accommodated. So these were the requirements of the new approach to deal with the big data. So, okay, the requirements, here we have a solution. Here we have a new concept coming in from the past close to, if to say Google and Yahoo implemented Hadoop back in 1998. So it's not a new thing actually, but it has gone to the sphere of everyone because of the data getting produced at everyone. Almost every one of you will have a smartphone or a smart tab, and every time Google will be collecting your location data, GPS will be commenting. So because of the digital data being scaled out, now everyone can feel that the data is very big and we need to handle that. And for that reason, this is the solution which has come across. So what actually is Hadoop? We understood big data. We understood what was the problem with the RDBMS system, how they were not able to cope that, because we were able to deal with data. We've already been dealing with petabytes of TBs of data with the RDBMS system, but the normal relational database systems were not able to handle that large data. For that, here comes Hadoop. So Hadoop I will call a distributed framework which provides scaling in three things. One is storage, one is performance, and the other is input-output bandwidth. You don't need to worry about if some of the terms you're not able to understand right now. One thing important, distributed framework, then a thing is scaling, then there are three things: storage, performance, and input-output bandwidth. Mainly it wants is we should be able to store data, big data. We should be able to process that big data in quick time so as to improve the performance, and we need to ensure that the input-output bandwidth being generated is also fast, that we have the input-output bandwidth through which we can generate that. So you can see in the picture actually there is an elephant, and so many things are coming in: file system, queryable database, archival store, fault tolerance, open data format. So you don't need to worry about all these things. First of all, I will tell you, I will just give you a gist of what Hadoop is. So after the next 5 minutes, I guess, all of you must be very clear on what Hadoop is. Hadoop is not a database. Hadoop is a framework which has in itself so many things. You would have heard Pig, Hive, HBase, Scoop, Impala, all those things are sub-projects of Hadoop. But we don't need to go into that detail now. Now what Hadoop is, I'll just tell you, there will be a kind of are connected to each other, and all 100 computers are being used to store data. In simple layman, one room I've placed 100 computers. I've connected all those 100 computers, and all those 100 computers are storing data in it, are using the resources over there. So that is what I mean when I say distributed framework. And when I say distributed framework, then comes what is scaling. There are two types of scaling. One is scaling in and one is scaling out. The kind of scalability which is there in Hadoop is scaling out. Scaling in means increasing the capability of a single machine. Then it's scaling in. If the current CPU is 1.5 gigahertz, if the current RAM is 2 GB, we'll upgrade the system, we'll make the RAM as 4 GB, we'll upgrade the processor as 2.3 gigahertz. That is scaling in. What do I mean by scale out? I will add another system, the same configuration, and both of them will together work. So that is scaling out. In Hadoop, we always scale out. I will like everyone to mute yourself. I'm able to hear some disturbances. Every one of you up there, please mute yourself. Yeah, so that was Hadoop for us. Just to again summarize that in a few lines, Hadoop is a distributed framework which stores data and provides scaling out, performance, and the input-output bandwidth. While going into the further slide, we'll first cut this part. Survey, can you help me with muting all the folks? I'm still able to hear some noises across. Yeah, this was actually a bit of history how actually we got to Apache, but I would like to have this here. Yeah, so we won't actually go with this slide now because this is actually a basic introduction, from where it started. So the main thing was, you can see from 2002 it is being hugely, implemented. There was a guy, Dow Cutling, which actually started with a nuts crawler, to get to a system where, that could scale out to billion pages, but he wasn't actually able to do that. So then Google took that thing from, Apache Nuts and converted that to Apache Hadoop, and gradually in 2008 you can see over here that Yahoo wins the 1 terabyte sort benchmark in 900 nodes. So what I want you guys to understand over here is these 900 nodes. This is a distributed framework, 900 systems in place which are connected with each other, and every one of them will store data, and we'll extract that data from here. So that is one thing I want you guys to be there. And when the data increases, I can scale out these 900 nodes to 1000 nodes. So that's actually scaling out, and that's actually the kind of things which it brings across. So now we'll get a bit deeper into what Apache Hadoop is. Yeah, it's an open source data storage and processing API. It's massively scalable, automatically parallelizable. It means, because I'm saying it is massively scalable, every node can actually process data simultaneously. I don't want someone else, some node to finish the task and then the other node will take it up from there. Everything will happen in parallel. It is based on work from Google. It's actually Google file system plus MapReduce plus Bigtable. And the current distribution which right now is the Apache Hadoop is solely the kind of open source, like it's free, we can have it on our system. Then we have companies collaborate and provide distributions of it. That is, we have the Cloudera distribution, we have the Hortonworks, we have the MapR, and then we have the AWS and the Windows Azure, supporting the web services of the Hadoop. So Windows Azure HD Insight is actually written by MS, that is Microsoft, to come to the big data and Hadoop world. But here I would love to have your attention towards the picture which is there. So how Hadoop will store data. Here we have the data in unstructured format. So what we'll do is, these are if you follow my cursor, this is one node, DFS, where it is written. This is another node, and this is another. So one major thing you understood by Hadoop was distributed framework and scaling out. So now the other thing is coming is how it will store. It'll break the data into chunks, and those chunks will be stored in the blocks, and those will be replicated across. By replicated, I want, even if one of the chunk got deleted, the Hadoop cluster will still be able to get back the data because it is replicated. By replicated, you don't look at the picture. Whatever I'm telling you, just try to visualize that. So suppose there is a 1 GB file I want to store into Hadoop. Say it is divided into 3 pieces, A, B, and C. A, B, and C are 3 chunks in which the 1 GB file has been divided. So how Hadoop will store it? It will store 3 instances of A, 3 instances of B, and 3 instances of C. By this I mean that A is being replicated to 3, B is being replicated to 3, C is being replicated to 3. And all of them will be scattered across the Hadoop cluster. To ease out things, say we have a 4-node cluster. So I'll be storing A and B on node A, B and C on node B, and C and A on node 3, and similarly like that. So what I'm saying is, if one of the nodes, even it goes off, suppose in the 4-node cluster my 3rd node goes off, still the Hadoop cluster will be able to recollect A, B, and C, the remaining 3, and get back the full file because the file is being replicated. So we have covered the concept of recovering things even if some of the nodes goes off. So we have 4 nodes, and in MapReduce we have 1,000 nodes, and if say 20 nodes goes off, we still will be having the data because the data will be broken into chunks and those will be stored, and even if some of the chunks are gone, because the chunks are replicated, we will still be able to get the data. So you can see DFS block 1, block 1, block 1. So it is like, the thing has been replicated across 3 times. Block 1, block 1, block 1, block 2, block 2, block 2, and block 3, block 3. So this is how the thing is being done. So then there is a MapReduce thing coming in. We don't worry about it. I'll come to the MapReduce thing. Okay, I'll just tell you here itself how MapReduce works. I'm very sure you guys, would be following what I'm telling you right now. To just give you a recap, big data, we should be no doubt what big data is. Then what problems we have with traditional DBMS, we should be no doubt with it. That's where big data came in. For big data, there were some requirements. For that, Hadoop came in. Hadoop is not a database, it's a framework. What are the benefits of it? Take out the system. Scale out is one thing I would like you all to carry on to take a page from this class. Then horizontal scalability, the way we will horizontal scale the system. Distributed framework. Then another important concept, replication. One of the Hadoop's main USP is replication as well as the MapReduce. So replication we've understood. It is replication which ensures us that okay, if 2 of the nodes goes off, we'll be still able to get the data. Then is the MapReduce. MapReduce will be another big thing which will take away from this course and even from this demo. So to give you in layman what MapReduce is, I guess when I used to study all these things, I didn't knew what is MapReduce, but because I've gone through the process, in very layman, what I can make all of you understand what is MapReduce. Suppose I want to do summation of 1 to 10, 1 plus 2 plus 3 plus 4 up to 10, and I have 5 nodes at me. I want to process a summation of 1 to 10 on a 10 node cluster or a 5 node cluster. How will I do that? I will ask the first node to do 1 plus 2, the second node to do 3 plus 4, the third node to do 5 plus 6, the fourth node to do 7 plus 8, and the fifth node to do 9 plus 2. So this is, I have mapped the problem to different nodes. Now all of those nodes will parallelly process and have their results. After every one of them have calculated and they have a result on their own, all those results will be reduced or aggregated and a final result will be given. So Hadoop employs this divide and conquer approach, and this is how it solves problems. So MapReduce is nothing but what I just told you. Map the task to different nodes. After every node has processed their task, all of them will collate that thing, will aggregate that thing, will reduce that thing, and give it back with the final result. The first phase is the map phase, and the collection of the thing is the reduce. Here you can see, a map happening here. You can see map happening here, map happening here, map happening here, and all of them can actually have the reduced thing and give it across. Yeah. So why we should use Hadoop? It's actually cheaper because we don't need to scale up the system. We just want low community hardware which can actually be there. We just want normal systems without much better configuration. 1 GB RAM, 520 GB hard disk is enough for me. But I'll use parallel data processing to cover up that. Then it's better suited for particular types of big data problems. So the kind of business problems we have here for Hadoop is risk modeling, customer churn analysis, recommendation engine, threat analysis, data sandbox, search quality, trade surveillance, ad targeting, everything which happens to you, all the ads you get in Google, everything is customized. If you search for a Google Nexus 5 on Flipkart or Amazon or eBay, you will easily see when you access your Gmail, there is a kind of ad being put out there that get Google Nexus 5 for this much discount and all those things. Because every step you make, every event you make on the net, on the web, is actually being surveyed across, and analytics is being done over that. And that is what, for the reason which we have come across here, to understand how to do big data analytics using Hadoop. And this will be the main thing, how to develop solutions using Apache Hadoop, using big data. So these were some of the, kind of the business problems which we can use over here. I don't want to put much of time over there, because I can actually give you one example for each of you, how the threat analysis can be done, how the point of sale transaction analysis can be done. But just to give you a fact, one thing which will actually come into picture is, all of you would have actually heard of smartphones, smart tabs, because today it is the age of the smartphone with our smart fans. But Gartner says it won't be far along that we will have a world of smart homes. By smart homes, what I mean is, when the person will get inside to the room, the sensors will get by themselves that the person is coming, they need to switch on the fan, they need to switch on the tube light, and the person will go out, those will be gone off. So we will be having wearable watches or wearable bands which will be recording the heartbeat, the blood pressure and everything, and will send out a notification to your mobile device. All of those will be connected, that your BP is running low, have something. So I just want to give you guys a kind of a vision, like how big data will actually revolutionize things, some way down the line. That all will happen. I would like you to, get onto the Gartner results. Gartner is actually a statistical company which gives out the trends and what will actually happen in the future. So these are all the things which will surely come in, but for that we need all the data coming from the sensors and coming from the the heart. Somewhere we have the sensor will generate data, and from that unstructured data we need to get to the reports, and those will be given to the mobile BI. So I guess, so I don't want to actually give each example for everyone, but these are the business problems which where Hadoop can be used. Yeah, all companies are using Hadoop: Facebook, Yahoo, Amazon, eBay, American Airlines, New York Times. So during the past 6 years, I used to say, since the very beginning of my career, that this will be something big coming up. But all the years I've been hearing it from people that big data is still a myth, big data won't come into picture, it's still RDBMS, it's still you will have to do a SQL server, still Oracle. So people still somehow believe that big data is still a myth, Hadoop is still a myth, it is a bubble which will burst. So I guess those guys don't know that Hadoop is being implemented right now in the Facebooks, in the Twitters, in the Yahoos, in the Googles, in the eBays, in the Amazon. So these are the companies which are using Hadoop clusters to better their systems, to better their processes, to have a better analytics at place. So then, how is the forecast growth of job market in Hadoop? So you can see, I took this thing from Indeed.com, and you can easily see from the January 2008, this thing started, and it's January 2013, and if you can still see, I don't know how much of you follow Gartner. After the class, I would like you to Google it, Gartner Hadoop, and you will have some of the reports coming in. So by Gartner, what he says is, by 2015, Hadoop and big data will be at the top of the things which will be driving whole of BI, that is business intelligence. So this was a kind of graph I wanted to show you, that this is something which is very demanding and very kind of fluently being selling in the market. So it's a very good skill to actually have it in your kitty to better the job prospects and all. Then again a kind of a rework, because you would have also heard about Pig, HBase. I just told that, so I didn't want to cover that also today, because when we will study that in the course, so we won't study only Hadoop. Hive, Pig, HBase, Mahout, Scoop, all of those will be covered inside the Hadoop class itself. So Hadoop says, a kind of a big project which has in itself sub-project. So Hive is a sub-project over there. Pig is a sub-project over there. Mahout is a sub-project over there. HBase is a sub-project over there. So, but basically it's actually consisting of, if someone asks you Hadoop outside, okay, you attend the demo, what is actually Hadoop? So you'll say it just have two things. One is the HDFS. What is HDFS? Hadoop Distributed File System. A file system where Hadoop will store all of its data. And then is the MapReduce, how it will process that data. So simple thing, what is Hadoop? Say, see, it is very simple. There is data, I need a place where you can store it, and after that is stored, I need to process it. So where it is stored, it's HDFS. How it is processed, it's MapReduce. So Hadoop, simple language, two things, HDFS, MapReduce. HDFS will store it, and the MapReduce will process it. And then we have other tools coming in, you can see over here, HBase, HiveWise, OL2, and I want you to have a look at the diagram. So Hadoop core is the HDFS. Here the data will be stored at the bottom level. When the data is stored, over there MapReduce will be done. MapReduce will be done, we will have outputs, then we will access that results, retrieve those results, then the data access, then the tools and the libraries. With the tools and libraries, I want to schedule a Hadoop cluster. After every 12 hours, this job should run. For that, we have something else. So we'll also go into that. So, but I don't want you guys to feel okay. That guy told what is he some names of HBase, HivePick, but we don't know what is that. So I'm giving a very kind of overview or high-level thing of everything. So after you go to the class, I'll just take 15 minutes more. After you go to the class, you have a fair bit of understanding of how the structure is. I'm not someone who doesn't know how things are. So HBase is actually is a database. HBase is a NoSQL database which is used to store data. So HBase purely is a NoSQL database. So then comes Hive. Hive is actually a data warehouse which will give unstructured data a structured kind of a field. So Hive uses Hive query language, that is HiveQL. Some folks must be knowing, covering both HBase and Hive in our session in our course. So then we have Pig. Pig is a data flow language. See, I have a weblog. Some of you might own a site. Say you have a site www.xyz.com, and after 1 month you want to know which all users have logged into my website and for how long they have logged in, from the geography they have logged in. From India, from Australia, from America, and how long they stayed on my website. So if I want all those data, all those persons who would have logged into my site would have, all the information would have been stored in a weblog. Weblog is somewhere like, in the web servers, all those information will be stored in the weblog. So I will have the weblog. Now I need to process that weblog. That weblog is unstructured. I need to generate insights out of that. So for that, Pig will come into picture, because Pig is a data flow language which parses the data and gives us the meaningful information. So that is where Pig will come into picture. Mahout is the machine learning. The machine learning, you would have actually heard about it. I guess the main requirement for in the future industry would be of data scientists, people who know data science, and this whatever I've talked till now is data science. I just not have named that. So the kind of position if we will be actually in, if we now at this stage learn what is Hadoop, what is big data, what is NoSQL is, we'll be in a position to be a data scientist by the time 2015 comes in, by the time big data reaches its peak. So Mahout is a machine learning project of the Apache. Just to give you an example what machine learning is, all of you guys would use Gmail, and if some spam mail will come to your thing, you will just click that mail and put that to spam. That it is spam, I don't need that. So what is being done is, when you put a mail as spam, behind the scene, a machine learning algorithm is being written which continuously learns what kind of mails you don't want. So if 5 times you have actually put a spam to the mail like Flipkart, Snapdeal, eBay, Amazon, this guy, Google will understand this guy does not want any retail ads. So the next time those won't come. So how that is happening? Behind a machine learning algorithm is writing. Every time I put a mail to spam, the machine behind is learning, okay, this guy doesn't want that. So you don't know, but when you are putting a mail to spam, even then there is a machine learning work. So that's the kind of idea I want to give you. This also has been covered. You can see HDFS. I told you redundancy, replication, MapReduce. The the internal thing, job tracker, task tracker won't be actually, I won't be able to cover that now, but I would like to cover the NoSQL part so that you can have a fair bit of understanding of how things work. So here is another thing, here is a 4-node cluster. You can see there is the name node, there is the data node. These three are data nodes. This is a name node. Together they are a 4-node Hadoop cluster, and we have a kind of a backup for a name node, that is secondary name node. So this is how a normal cluster will look like. So when we say a 100-node cluster, one node will be name node, and all will be data nodes. So name node will actually store where all the data is stored in the data nodes. Suppose there is a file called 100 GB, 25 GB is in node 1, 25 GB is in node 2, 50 GB is in node 3. So from where till where, which location the data is stored, all the information will be with the name node. Name node won't be stored. So this will be kind of the structure Hadoop has. Then the MapReduce job, I won't like to go much deeper into this, but the main thing is the task, first of all, it is in map, and after the results are being shuffled, sorted, the results have been given, we again aggregate that, reduce that into a common output. In detail, we'll actually study this in the course itself, but it's actually the main thing which will be driving things over here. Then this is the Hadoop ecosystem. All the things I told you. Here you can see these are the web browsers. Then this is the unstructured data, Flume and Scribe. Sorry. This is actually you don't get parade after this, but this is actually full data science. When they say there is a guy called data scientist, so you should have fair bit of knowledge on this. And at the end of this course, you guys would be knowing everything across. Like if someone asks you what is Jackal, what is Scribe, what is Uzi, what is Scoop, so you guys won't be like okay, I don't know this. So you guys would be knowing everything. So this is the unstructured data. Flume and Scribe are actually the web servers which actually get the web logs from the net. This is RDBMS, this is Scoop. Scoop is used to transfer the data from RDBMS to the NoSQL. There is no point actually telling you what each of these does right now, because it will be actually too heavy, but I just wanted to present to you, okay, this is, see, here is the machine learning, here is the support, I can schedule things, here is the Hive coming in the warehouse, here are the systems which can manage or monitor the Hadoop cluster, there is the Ganglia, there is the Karmasphere, then we have the HBase, so here you can see the Uzi, we want to schedule some things over there, then we have the machine learning Mahout. Here we have the analytics, the BI coming in, intelligence dashboards and all reporting tools. This is full ecosystem aspect. Yeah. So another thing, a same kind of thing. There is the name node, there is the secondary name node, data nodes are there, and things are running. This is the master, and this is the slave. More details, no need to go further right now. You need to understand. Okay, there is a name node, there are data nodes. The name node stores where the data is. It stores the data. This have already covered Mappa, Cloudera, all the distributions. Yeah. Now, can we compare RDBMS with Hadoop? No, because Hadoop is not. RDBMS should not be compared. What should be compared? RDBMS should be compared with NoSQL, because NoSQL is a database. Now, a new term. What is NoSQL? You don't know what is NoSQL. We have come to know what is the data, we have come to know what is Hadoop, we have come to know what is master node, name node, secondary name node, okay, all those things. But what is NoSQL now? So Hadoop is not a database, but NoSQL is a database. And NoSQL is not only SQL. First time I heard NoSQL was, I guess I thought there won't be any SQL being used. But actually it is not like that. It is not only SQL. I will be using SQL plus over and above that I'll be using some other things which will require me to have this thing. So now a bit of kind of thing I would like to hear, how the landscape is changing. This was the time has come when RDBMS is actually fell to the backdrop, and there is a new thing coming up, that is the NoSQL, which includes Hadoop, which includes all the Cassandra, MongoDBs you would have heard. So these are the flavors of NoSQL actually present in the market. We have the document stores, we have the key value stores, we have the white column stores, we have the graph data stores, we have the multimodal data stores. Very quickly, I want to give you guys idea about this. You can surely, go to the next slide saying, a bit of idea about, okay, NoSQL, what does that happen? Same thing is here, there is no schema in NoSQL. In the document store, my every record will be stored in one single document. The document will be assigned for every record. In key value store, everything will be recorded in a form of a key and a value. For every key there will be having a value, in that manner things will be stored. In byte column stores, everything will be stored in a column oriented fashion. You know, in RDBMS, everything is being stored in a row oriented fashion. But here, it will be completely opposite, column oriented fashion. Then we have the graph data store. If you guys are active on Facebook, around 6 to 7 months back, Facebook implemented the graph algorithm, you know, with which you can search now, find all friends who live in Manhattan and know cycling and love this thing. So that is actually a graph search, you know, happening behind. And the DB which they have used for that is Neo4j, you can see over here. So that is graph data store. Then the multimodal data storage, if you feel like, you know, some of the data can be handled by Hadoop, some by graph data store, some by documents, so we can have a hybrid kind of thing for all of this. So things from this slide I want you to take away. One of the very important document store is MongoDB. MongoDB is a document store. Key value store, DynamoDB is a very big one. Byte column store, so see here you can see Hadoop, Cassandra, all the things coming in. Graph data store, Neo4j. So just a slide to give you guys an insight about NoSQL. NoSQL modification why it has come across, because the reason, you know, or everything getting digital, so many data being collected, RDBMS is not able to do that. So won't spend time much on this. So NoSQL products, so you can see Cassandra, MongoDB, CouchDB, all the things. SRM base also we don't need right now, Capstone also we don't need. Okay. Now, okay, we've understood what big data is. We've understood what the problem is. We've understood what are the challenges which that brings across. Then we have seen, okay, new approach we need, what are the requirements for that. Then we did what is Hadoop. Then we understood, okay, HDFS, MapReduce, scalability, replication, all those things. Then, okay, there is something called NoSQL which we can compare with RDBMS. What is that? We did that. Now with the data, is there any security risk? Obviously there is security risk, because with everything which comes, we always need to ensure that the security is not compromised. And even we won't do that here, because my everything will be placed at one single location, because, you know, whatever I'm doing on the net is being stored somewhere, and with big data I've collected information from, say, myself, Namit Taneja. Every information is being collected from the web and stored somewhere. So, but the problem with this is, now because every information about me is aggregated and stored in one place, if some person by hook or by crook gets to that data, you know, I'm lost. I've been ruined, because he's every detail about me. So because the data is being aggregated, hacker attacks one source and gets everything. What is his salary, what is his Aadhaar number, everything will get. So that will become one thing. So how we can reduce that? We have so many things coming in. So we'll actually encrypt the data. We need to have a multi-factor authentication. We need to have the data loss prevention happening. So these things will be covered, you know, when we are going under. Now this is one thing also I like to, this will give you a fair bit of idea, okay, what actually we're going to get in this course. So here you can see, here's the community hardware, community cluster we have, say 100 nodes. Every node in a cluster has a Linux server operating system in it. In that we are storing data on HDFS or Cassandra or GPFS, like NoSQL or the Hadoop. So then when the data is stored, over that we need to process the data, MapReduce. Over that we have the data access thing, Hive, PageBase, data pipelining things, Scoop, Uzi, Avro, Zookeeper. Over that we have a machine learning algorithm running behind with NLP. NLP is natural language processing. Over that we've implemented security, and over that we are reporting, modeling, and investigation. So my, you know, intent in this demo was not actually to delve you guys deeper into the Hadoop thing, because anyways we're going to do that. My attempt today was to give you a fair bit of understanding of how the big data architecture will actually look like. So I guess you guys should be okay just to understand, okay, which part does which part. Obviously you won't be knowing what Hive is, what Scoop is, but actually kind of, you know, vision would be clear in your mind, okay, this will how things will work. Here I will be having notes, here every node will have a operating system on Linux. Here I'll store the data in LGFS. After the data is stored, I'll process that using MapReduce. Then give the data pipelining. Over top of that, in the back end, machine learning would run. Over that, I will implement security, and then I can report data out of it. These are the same things. So this is actually, what I wanted to give you guys, fair bit of idea about how the architecture will, and in the course we'll actually cover, I guess after the course, whatever is there in this slide, I'll be covering that. So after that, you would be knowing in practical how you can implement Scoop, how you can implement Avro, how you can implement Zookeeper, how you can implement Fig, how you can implement Mahout, how do I need to ensure security, what is Linux, what is NoSQL, what is MongoDB, what is Cassandra. So you would be, through that, at the end of the course, and I will ensure that, whatever you guys have problems, I'll cater to that. So now if you have any questions to ask, you can surely ask that out. Any questions then? Mohit, Rajesh, Saurabh, Shiva, Gautam, Balaji, Ehsan, any one of you, any questions? Any questions?
What will be the charges for this course?
Who's this? Who's this actually?
I'm Mohit here.
Okay.
Hello.
Okay. Yeah. Of the charges. So we will get back to you with the charges and when the course will be started and all those things.
Okay, and can I know what's the duration of this course and how many days it will be and how, timings and all those things too?
Yeah, all those things will be communicated. She will be taking care of the admin. So please get into touch with Mohit on that. I guess.
Thank you.
Yeah. So any doubt anyone has on
It would be
the
helpful if you can send to.
big.
I'm just saying it would be helpful if you can send that page to all the participants. So I was just saying if you can send the details to all the participants. So Namit, I just have one question on whatever you explained till now. So over here, what I have heard about Hadoop is like most of the companies are just placing the Hadoop layer on top of or the big data, whatever they are implementing on top of their current database or current data warehouse wherever they have. But what you explained here is like we can build it from scratch. So which one is like, do we build it from scratch or we use the existing data warehouse and build on top of it?
Yeah, it is actually a very good question from your side. See, what actually the clients are coming up with, we need to have a business case for that. Then every company, they have hired some because if you will attend the course, you will know Hadoop. Some company will have you as a Hadoop developer or a data science developer. So they need a business case for that. So the business case which is coming to the company is like that. They want some kind of analysis to be done over there, FB, LinkedIn, the weblogs and all those stuff. So if that company is willing to even shell out its RDBMS structure to us, we can even use that. So it's actually both things are available. If we have a data warehouse architecture in place, then we can put Hadoop over top of that. So see, if I give you an idea, here we can have the RDBMS being placed, with the Hive, the pig, the base. So there will be a RDBMS and there will be a Hive kind of thing. The Hive kind will store all the unstructured data and the RDBMS will be stored in the RDBMS. And I can anyways report out of even RDBMS as well as Hive. So both the approaches are actually being used, but what I am currently doing is, it is from the scratch.
Okay, and I have two more questions.
But
what is this data? What is this?
Yeah, it will actually be prudent to go starting it from the scratch when I have a RDBMS full architecture in place. So if there is a company and they're doing something for a client on the RDBMS, say there is a client, say X, we are doing a ETL project for them on the RDBMS. Now they want some Hadoop kind of project on them. So then we'll try to integrate those RDBMS architecture with the Hadoop architecture, because that doesn't go to waste. That is the thing which we've created.
And what is this data pipelining like? I didn't completely follow. So data pipelining is like once the data is built out, then how the data flows. Is that data pipelining or something else?
Data pipelining is actually how the data will flow, like from where the data will flow and how I can make that happen. So to give that a better, like I've written Scoop over there. So Scoop is actually a tool which gets data from RDBMS to a Hadoop. So if we have a kind of a SQL Server database and I want that data to put into Hadoop, I can do that. That is what I'm saying. All that is data can be put into Hadoop using Scoop. And similarly, vice versa. If I have a data in Hadoop, I want to put that into RDBMS and report out, I have Scoop for that. So that is how the data will be flowed across. Then there is Uzi is actually a job scheduler. What it'll do is it'll be scheduling the job which will actually make the data flow. So all of these tools as such will make the data flow from one place to the other. That is the reason why the name data pipeline.
Okay, and where does the cloud architecture fit in the complete application or complete architecture? Because I don't see anything for the. I know there is a cloud thing also with the Hadoop, but I'm not sure where it will fit into this.
Very fair and good question. You have done your homework, I guess. So everything I've talked about right now is I've talked in physical. Like suppose I work in XYZ company, they will be having a Hadoop labs of their own, and a 100-node Hadoop cluster will be set up, and I'll be doing things manually over there. But what is in the trend, or what Gartner or Huffington Post predicts what will happen 5 to 10 years down the lane, everything will go on cloud. I won't be having physical nodes over here. There will be nodes on the cloud. Suppose I've took a subscription from Amazon, and they have given us say 100 nodes, but we have specified to them, when out of those 100 nodes you can see close to 80 nodes fill, we need to add 10 more nodes. So that will be taken care of by the Amazon system itself. They will take care of the data is increasing, they will add more nodes and will charge you like that. So almost everything will move out to cloud gradually. So there's something in place. All of these Hive, Scoop, everyone physically in our system, they will be on the cloud and we'll be accessing them using a client system. So that's actually how the future state will be.
Okay, thank you. Thanks for responding.
Namit, can you go to the slide where I think you have like all the components or all the tools, I guess. I have one question. Yeah, if you go before, there was no, not this one. Like I think before. Yeah, not that. Yeah, one before I think.
This one, no?
No, it was like lot of things. There were lot of things, and and all the this one.
Yeah.
So in this one, so I mean, we were talking about this. You were explaining, but in specific, what do you touch in this case? Like what all would you be teaching us in this course?
This is actually a very good question from your end. This will actually answer some of the questions from everyone. See, when we talk of Hadoop, no, Hadoop is a big project. Even if you will Google Hadoop, Hadoop is a big project which contains in itself many more sub-projects. So see, if you can see the 5 and the 6, the HDFS and the MapReduce, they are actually Hadoop. And when I say Flume and Scribe, these are Apache Flume, Apache Scribe. So everything is Apache actually, Apache Hadoop. So Apache Flume will get weblogs from the web servers. Apache Scribe will get the weblog from the web servers, which we will put into the HDFS and which will be processed using MapReduce. Then if we have any job, we will process that using Apache Uzi. Then this is Apache Hive coming in with the high level interfaces. This is Apache HBase, and this is Apache Avro, this is Apache Mahout. So it's actually basically we'll be covering in full detail what is HDFS, what is MapReduce, what is HBase, Hive, and then surely we'll have to cover Apache Flume, and then I like to give you some inputs of Apache Mahout as well, because that is actually the thing which will be driving things over there. And then we know actually that how to report out of that. So that thing won't be these 4 and 9, the analytics part and the dashboard part. We can actually do that using any BO or a reporting to SSRS or any Cognos or anyone. So basically, you can say, okay, out of this, I won't teach you Apache Scribe, or I won't tell you what is Karma Sphere. At the end of the thing, this will be the code, but the end of the thing, you will be knowing, okay, Karma Sphere, if there is a thing, what does it actually do? If there is a thing called Ganglia, what does it actually do? So a fair bit of understanding about everyone is what I would love all of you. Because if I teach you what is Apache Hive, Apache, LDFS, Apache, MapReduce, Apache Uzi, and then you go out and someone asks you, okay, what does Scribe help you to do? You actually took a Hadoop course. What does actually Apache Scribe do? And you were like, that guy told me that. So I would try to give a holistic kind of a thing, whatever I know. I would actually love to fall into a proper course contents where I'll follow only this. Whatever I know as of now, I will try to delegate all I actually know or prove to you. So that will be actually what my intention will be during the course session. I guess I would have answered your question.
Okay, thank you, Namit. So I have one more follow-on question. Generally, I've been searching jobs before, and then I haven't seen much of Hadoop. So, I mean, probably the participants can answer also this question, but I mean, is like Hadoop just only for Java developers, or is it like a special kind of thing, or is it mainly for a DB folks? Because mostly Hadoop, whoever is doing is like, people who are in database side. And, what do you think, or what, other people who are in the meeting think about this? Like, who does it?
Yeah. From which background you are? Like,
I'm from Java.
You're from Java. Yeah. So, I don't know, like, any your years of experience? How much?
I have like 12 years experience.
Can I have a good name? Can I have a good name, please?
My name is.
Okay. No issues breaking. Actually, I didn't got a name. But to answer your query, I should see. I don't see a reason why you, if you're a Java resource and Hadoop, and you search on a job portal that if there are jobs available, I won't actually agree with what you have said that you're not able to see much jobs, because as I have told the kind of experience I have, and I don't know actually Java. I'm not a Java resource as such, though I've gone into a bit of that. So Java plus Hadoop as of me is a very deadly combination, which is gradually being shifted to R plus Hadoop. So if possible, I will try a little bit of R over there. Whatever I know, or I'll try to pass on some information about R itself too. So, but as such, almost all other folks out there, Balaji, Gautam Rastogi, Ehsan, Anaga, all of them can also answer. I guess I won't agree with the fact that you're not able to see jobs of Hadoop, in the job portal. So, yeah. So have I answered your query? Or if anyone else would like to answer his query, they're open to that. But I would actually want every one of you to go to naukri.com, monster.com and search for jobs with title Hadoop. I want you to.
Yeah, I agree with you. For me, I think I have searched a lot, and I found that Hadoop is very much demand in the market. So that's why I'm here.
Okay.
It's
and you
Asan.
Can I have a good name?
Asan.
Okay, Asan. So, same with me, every day I'm getting, closely 2 to 3 calls in LinkedIn or my mail that if you want to have a move out, you please. So Hadoop is a kind of skill which you have in your kitty, I guess, till 2020, because I still feel, we are Saurabh is a bit early into this. I feel at the moment when Bitcoin will actually come into the equity market will be close to 15. By 2015 we will be having business running like crazy in this field. So I guess we are still early in this. So if you guys can learn a bit of Hadoop, the people who will be driving data science across everywhere in India, because as Gartner report suggests, there will be a shortage of close to 2 million data scientists all over the world. So from where will those data scientists come? Will be the guys from the Java, from the UK, from other backgrounds who have Hadoop knowledge, who have data science knowledge, who know how to mine the data out, which will be the data scientists. I guess it's a very good initiative by all of you folks to come here and together we'll learn. I'll learn from you guys. Whatever I have to offer, surely I'll offer that. So that is kind of a thing I'll be looking forward in this course. Any other questions? Rajesh, Saurabh, Shiva, I have not heard them saying anything. Gautam, Rastogi, even Balaji has not spoke something. Naga, so any questions, any query regarding anything, you can put that forward.
Namit, I've already asked my questions over here.
Okay, I'm sorry if I
Okay.
yeah. So okay, I guess almost everyone I guess is happy with the things and they don't have any further queries. I guess Surbhi will get back to you with the details, like when it will start, how the duration, all those things will be taken care by Surbhi. So I guess we will wind up the demo class here, and I would love to see almost every one of you in the regular classes whenever we'll be starting. So thanks a lot. Till then, take care.